Okay, we've looked at the electrolysis of molten sodium chloride. Now we're going to look what happens when you electrolyze it in aqueous solution. And this is probably one of the most difficult things to understand at GCSE chemistry. Now, obviously, for this to conduct electricity, whatever you've got in this beaker, the ions need to be able to move. So they either need to be molten or dissolved in water, aqueous solution. And then they can move about and move the electrodes and carry the current. Okay, so if you've got the positive, if you do molten sodium chloride, the positive electrode, you get chlorine gas. And you get the same in aqueous solution, you also get chlorine gas. So that at least is the same. So you get some chlorine gas coming off from this electrode here. Little bubbles of chlorine forming there. But at the negative electrode, it's different. In the molten one, you get sodium metal. Whereas when you do it in aqueous solution, you don't get sodium metal, you get hydrogen gas. So you're going to see, you won't see sodium, molten sodium forming here, you will form hydrogen gas. And really that's not surprising because we know that sodium reacts very violently with water. So even if it was formed, it would just react away straight away. So you're never going to get sodium forming there. Right, we've got to think why we get hydrogen gas forming and what that means. Right, so when we think about what's going to go to the negative electrode, it's going to be positive ions. And the positive ions we've got in solution, well, we've got two. We've got sodium ions, and we've also got H plus ions. Now, where are the H plus ions coming from? Well, they are coming from water. Now, if you've done the equilibrium topic, which you probably haven't done, then you're probably familiar with this. But water, that reversible arrow means that the reaction is reversible, splits up into H plus ions and OH minus ions. It's about 1 in 10 million molecules do that at any one time. So most water is covalent water. Hardly any of it is split into these ions, but a tiny bit will. And that's of course why even distilled water will conduct electricity a little bit, because there are some ions in it. Now, which ions are going to go to the negative electrode? Well, we're going to get H plus ions are going there from the water, and we're also going to get Na plus ions from the sodium. And we've said before, we know that the negative electrode, so here's the negative end of the battery, is pushing electrons down that wire into the graphite electrode, which we've got there. And either the H plus or the Na plus has got to accept that electron. Now, which one is going to be most willing to accept it? Well, let's have a think there. Look, I've drawn a very small reactivity series here. So the most reactive metal at the top, I've just done sodium, most reactive, then zinc, then hydrogen, which of course isn't a metal, but we know we do put it in the reactivity series. And then the least reactive is copper. Now, when they haven't reacted, they are atoms. So you've got sodium atoms, zinc atoms, hydrogen molecules, not quite atoms, and copper atoms. After they've reacted, they've lost electrons and they've all formed those ions. So sodium is very reactive. So sodium, it hates being this, and it loves being that. So there's no way this is going to be ready to accept an electron to turn it back being into something it doesn't like, which is the Na atom. Whereas if we look at, say, hydrogen, that's a lot less reactive than sodium. So this quite likes, we'll just say it likes being hydrogen, and it mildly dislikes being a hydrogen atom. So if it comes to a competition between these two, if you're giving away an electron, which one's going to take it? The sodium plus is not going to take it, the hydrogen does, and that's why we get the following reaction occurring at the negative electrode. We get hydrogen ions accepting electrons and turning into hydrogen atoms. And of course, as soon as you get two hydrogen atoms, they join together to form a molecule. So we need to balance that with a 2 there and a 2 there. We do not get any sodium forming. But there is another consequence of that. If we look at this, is the splitting of water equation, yeah? Well, all of these hydrogen atoms, when we split water, we keep removing them, okay? Because they keep going there and get turned into hydrogen atoms. And what that causes, if you remove, so we're removing them, that causes more and more water molecules to split up. And as a consequence of that, what's going to accumulate is these are going to accumulate hydroxide ions. You're going to get more and more of them. And if you remember, if you've got hydroxide ions in solution, that will make the solution alkaline. So the solution, the sodium chloride solution, when you electrolyze it, becomes alkaline. So we get, we get three things happening there. We get chlorine gas giving off at the positive electrode. We get hydrogen gas giving off the negative electrode. And this solution, well, it essentially turns into sodium hydroxide solution. Let's just see why that is. So which ions do we start off with in the solution? We have got Na plus, H plus, Cl minus, and OH minus. Right, so what happens during electrolysis is the chloride ions, they get removed to form chlorine gas. The hydrogen ions get removed and they go off to make hydrogen gas. So what we've got left in solution are aqueous sodium ions and aqueous OH minus ions. So we've essentially got a solution of sodium hydroxide, which you hopefully know is an alkali. So that's what happens during the electrolysis of sodium chloride solution. Just to summarize, we get the positive electrode, we get chlorine, the negative electrode, we get hydrogen, and left over we get sodium hydroxide solution. Right, just before we finish this video, let's see what would happen if we electrolyze, instead of sodium chloride, we did copper chloride. Well, what would happen is, let's see what ions have we got at the positive electrode. We are going to get the negative ions going there. So we're going to get chloride ions and hydroxide ions going there. Positive electrode acts as an electron hoovers an electron off one of those. It actually gets it off the chloride ion. So the chloride ion gives its up electron, forms Cl2. I'm just balancing that, double everything. But the negative electrode, well, that's more straightforward in the sodium case. Which ions have we got there? We have got Cu2 plus ions, blue, and we've got H plus ions. Now, which one of those is most willing to accept electrons? Well, it is actually copper, because it's less reactive than hydrogen. It's one of the few metals which is less reactive than hydrogen. So in this case, what happens is the copper 2 plus ions, the electrons come down the wire here, and the copper 2 plus ions, they accept 2 electrons, and you're going to form copper metal, which will be deposited. Some copper metal deposited on the graphite electrode here. So you will actually get, you won't get hydrogen gas there, you'll get copper. That's because copper is less reactive than hydrogen. But for almost any other metal, remember the reactivity series, they're nearly all above, apart from silver and gold, they're all more reactive than hydrogen. Yeah, look, I've already put sodium and zinc in there. Most of the metals, you're going to get hydrogen gas given off there. You're not going to get the metal deposited when it's in aqueous solution. If you want to get the metal deposited, the only way to do it is not use aqueous solution, but use a molten, use the molten ionic compound.